content of the HTML via window document body path node inner HTML, and via regular expression we replace the body tag, or better, we just add an event handler on keybrace is keyff event, where event is just a variable where various information about the event is stored. A mini keyff is just a mini JavaScript keylogger. This is one of the examples we had to overcome with browser incompatibility. Internet Explorer, for example, has another member of the event object that stores the key code. With Internet Explorer, it is event.keycode. With any other browser, it's e.wish. Alright, then we just reverse the character by getting the character from the jar code and append to a global variable. We just call document all keys the character that has been pressed. Getting the key information is exactly the same as with cookies. Next time the client polls, we just have him return all keys to the server. Now, finally, there's a little bit more interesting requirement, because it's a little bit harder, namely that the malware should be able to work across links on the same page. The solution is, again, not so difficult. We can use XML HTTP requests. It's great. One of the few great things about Ajax is that we are now able to do arbitrary HTTP requests via JavaScript. Just like with window, with onKeyPress, we add another event handler to the body tag, namely onClick. And whenever a click takes place in the window, it is caught by the ClickFF event. What comes in handy is additionally that there is some call it vulnerability, I wouldn't call it that, but when someone points his mouse pointer over a link, the href attribute from the link tag is shown in the status bar. It is not shown what is in the onClick. So when you point a mouse over a link, you think to see what kind of page is loaded in the status bar, but via onClick you can just point the browser to basically anything via JavaScript. This was a big thing in 2004. Microsoft even advised to better type in URLs instead of clicking on them. What happens now when a mouse button is pressed? The simple case is a normal link was pressed. In this case, just use JavaScript to gauge the href attribute and the target attribute. We want to be compatible with frames. So even if it's a frame, a page that uses frames, we want to show the page in the correct target, and perform a simple XML HTTP GET request, and put the output of the request, so the response, to body parent node inner HTML of the right target. This has two implications. The first one being that the URL in the browser bar will not change while you are infected. It will look to the client as if the browser always is on the same domain, because just the content of the body tag is exchanged depending on what page you're currently on. This makes another problem, namely that relative path may be wrong. So if you go to another subdirectory, the images that are loaded via relative path, for example, won't be able to load anymore, but there's a simple solution to this, namely the base tag. And via the href attribute, you can just give him the new relative path from where to load all the images, which makes it easy because now the browser is handling the relative links and we don't need to do that anymore. The complex case is if a form button was pressed. We also want to be able for the malware to stay alive even though a form was submitted. Luckily, we already have our onClick handler. So the event object tells us in which form the submit button was pressed. Now we need to loop through all the elements of the form because our on-click event handler prevented the form from actually submitting. So unfortunately we can't use xform.elements because for some reasons, some strange reasons, it doesn't contain all form elements, but rather we have to manually get all input elements, all text areas, and all select boxes, for example, with checkboxes or radio buttons. All right, then we just do the XML HTTP request and again setting the inner HTML to whatever the request returned. Okay, this is possible when the user clicks on a link that shows to the same domain. But due to the same origin policy, which is basically a good thing, XML HTTP requests won't allow requests to alien domains or other domains. The solution to this is that the server, of course, can request anything it wants. So therefore, whenever the infected client leaves the current domain, we just send the server a message that he needs to request a page for us. For example, post type. Here we pass in the URL, the URL, and the browser, the server takes care of requesting the page and returning the input. And again, the inner HTML is just set to send to the client for display. Finally, we want to do remote shoulder surfing. That's again a very easy one. All we need to do is to continuously send the top document body path parent node inner HTML to the server, and the server just can display it within an iframe. Okay, and the final requirement was to remotely control infected browsers. Actually, I would have loved to show you this live, but unfortunately my VMware let me down today in the morning. So I quickly made a couple of screenshots. I know it's not the same as a live performance, but I'm sure you will see what the system we implemented is about from the screenshots. So this is just a plain screenshot from our control page. You have on the left side the victims, and in the middle the active module, and on the right side a couple of modules, what you can do with the browsers that have been infected. For example, you can send him an arbitrary JavaScript command, you can get the remote page, you can get the cookies, you can set the page to anything the server wants, you can set the page location, you can set the page content, and here you can set the page location. The alpha indicates that it's not very good, well working so far, but we're always working on improving the system. Then we have kill victim's browser, for example, using some denial of service vulnerabilities in the browsers. You can also crash their browser if you want to. And finally, you can get the key presses. All right, so this is just a very, very simple web application we wrote for demonstration purposes. It is actually vulnerable to all kinds of vulnerabilities. You have cross-site scripting, you have SQL injection, you have file inclusion, file uploads, everything you want to. I'm just using this application to show you how the proposed system works. It's actually a gambling site, so you can play roulette or whatever you want on this page online. It's not online. We wouldn't put such a vulnerable system online. It just ran on a different server, internal server. Okay, so into this application we inserted a small JavaScript, namely the one that loads the JavaScript Trojan. It's as simple as putting the script tag there. In this case, we just assume we found a permanent cross-site scripting vulnerability. If you only have a dynamic or non-permanent cross-site scripting vulnerability, you need your victims to press on a link, for example. Okay, now the victim visited the page and becomes effective, which is shown as such an entry to the victims list. You know what kind of browser you have, and in this case, we're just sending the client manual message, namely alert you have been owned. You just press the execute button and the victim gets the message that he has been owned. You can also get the cookies as shown here. Down there you can see the cookies. You can get the screenshot. This is what I call remote shoulder surfing. Just press get page snapshot or permanently get page snapshot, and you can always see what pages the victim is surfing on and follow him around anywhere. Okay, it also works with two clients, for example. You just have two entries in this area here, and as you can see, we were on a different page before. Whenever the victim changes the page changes to in our control page of the cross-site scripting Trojan. Okay, now you can also log into this portal using a username and a password and submit it, which is great because this can demonstrate our get key press functionality. In this example, I used Control Paste, Control V before it was even locked, but you see the username I used was Gek and the password was passwd exclamation mark. Okay, now even though the client logged in, we're still active with our get page snapshot, and now we as attacker are logged in too and see everything the user sees, logged in as the user that has been infected. Now we have an external link just to demonstrate you that the system is able to work across domains, which points to www.seconsult.com, and the URL stays the same, but it is loaded the page that the external page that the client went to, and still you can get the screenshot. Okay, and you can also point the server, the client, to another page location, for example, DeepSec. Yes, it says alpha for a reason there. And you can send arbitrary content to the client. Well, that's it from my side. Just in time, as I see. Any questions?
Does it work if the screensaver is enabled?
Excuse me?
Does it work if the screensaver is enabled?
If the screensaver is enabled, well, actually the screensaver doesn't have any impact on the page. So it's just a matter of the browser. Whenever the user manually enters another URL, the malware becomes ineffective, because the new page is loaded. But the screensaver doesn't have an impact on the Trojan itself. Yep.
Have you considered implementing something like a proxy server that gets you a view of the intranet from outside?
Not yet. Not yet.
Really,
that's true. The problem with getting the intranet is that you have to, in some way, brute force the IP address of the intranet, because you don't know. Or another way would be there's a vulnerability where you can get the history by brute forcing the links, just showing a huge list of links and checking what color the link is. And if the link was already visited, it is another color. That would be, for example, a way. Yeah, actually, it's a good idea. Right? Anyone? Well, thanks everyone for listening.